Okay, video 178. It's Saturday. We're going to work on some fancy filler for the coffee table. So basically, if we make the tabletop out of just pure epoxy, it's going to be very expensive. So we need a cheaper filler material. Not only can we get a filler material, but we can also make the table look even more expensive with the filler material, right? Because just a epoxy pour with some color probably isn't going to look that awesome, right? And we want some way to distinguish ourselves, so we can save some money by using some type of filler, right? So most fillers in an epoxy table are just wood, right? So if you look at most of the epoxy tables, like you go epoxy table, Etsy, just go look that up for a second, you're going to notice that the filler material, I mean, obviously it's kind of pejorative to call it a filler material. You wouldn't want to market it this way. But if you really think about it, the filler material is the wood, right? And I say that because the wood is the least expensive part because the epoxy is so expensive. Right? There's also a contrast aspect, right? Where with this nice blue kind of complements the wood. But yeah, if we want to, we don't have much money. We got to figure out how to make an awesome table. With the technology we have, with our current skill set, how do we make something? How do we make something that's awesome enough to compete with something like this? Like, this looks pretty awesome, right? This thing right here, epoxy dining table, epoxy table, clear green epoxy wood table. I think this looks awesome. This looks awesome. The shadow underneath that, everything about it, awesome, right? Oh god, this looks awesome too. So there's like tons of really awesome stuff on Etsy. I like how it looks like they milled this. They probably milled this on a shop bot after they were done with it. And this is like a cutting board. Yeah. So I kind of see how they did that. And I kind of have a similar idea in mind for how I'm going to produce my slab. But yeah, so if we want to do something like this and get it professional, we're gonna have to think about some of these constraints. So this looks awesome. Like, all this stuff looks awesome, and look, they're charging an amount of money where I could really get started if I can start to sell things for this amount of money. So we got to just take a shot at this and use the materials we have to create something awesome and unique. So with that said, let's get at it. So let's go open up the this project folder for a second, and we're gonna keep this little slideshow open over on this side because we're gonna want to reference some of the dimensions of this coffee table when we're trying to figure out how we're going to make some filler pattern to go inside the table, right? So we want some type of unique kind of filler pattern, and these are the constraints. So we want to make some type of scaffolding that kind of fits this. So I don't know exactly how we're going to do it. I guess we could start with just making a basic scaffold, and then I don't know how we're gonna do it. We'll figure it out though. But we definitely want to make something where we can kind of bolt it all together and just have something that kind of works. So if I'm looking at the current bolts that I have in stock and seeing, you know, how much space does that take up? It looks to me that we take about 1 inch, 1¼ inch is being taken up by this. So I really ideally wanted the table to be kind of like, I was thinking, you know, 2 inches thick would be good, but I think 2 inches thick is a little extreme. And the thicker the table is, the more it costs to make it. So I think we have to design across the constraints that we have. And so 1¼ inch seems to be what the design is telling me that I can use. I'm looking at a piece of material, a little mock-up. Like, I have a physical prototype that's going to help me figure out what I'm doing, and you can't see that, but just you gotta trust me that it's there. So we're going to say new folder, and we're going to say cough tab, I'm going to call it cough tab heatsink. It's going to be a filler that goes inside of the coffee table, but right now it kind of looks like a heatsink, so I'm going to call it that, cough tab heatsink. And then we'll just go new text document, and we'll call this coffee table heatsink. So CHS for cough tab heatsink.scad. Okay. Then we'll go open this with Notepad++. We'll go drag this over here, and we'll get to work on it. Also, we want to keep track of the previous models, right? So, hackish linked list. Right, so hackish linked list of models. So yesterday we were despairing and trying to get something. We were scrambling to make some type of simple little product we could sell because we were panicking. And then we tried to make that simple little product. We wrote some diagrams, and then we're like, you know, this is actually a bad idea. And that was this file. So this was the previous thing we worked on. So previous model is this thing. So we might want to keep the full path here because it's in this B folder, B for bases. And then current model is r/g/upat/models/cough tab heat sync, right, /chs. CHS is the namespace that we're going to use for that. Right, and then we can kind of align that nicely. Then also, let's go into we have an index file for this stuff. So if we go in models and we go into dex, we have like an index, I don't know what it's called, 00 dex or something like that. And then in here, we're going to say model, and we have m/cough tab heat sync, and that's going to be chs.scad. Okay. So I gotta get stuff done quickly. Every month I lose $10 more, $20 more in my bank account because of maintenance fees. Alright, so if I don't make any money, I'm losing money. Like, yeah. If you're not making money or losing money, it's not just true in my circumstance, it's generally true. Because it just costs money to exist, right? Okay, so we got this hackish linked list of models. Let's just say the usual SCAD constants. And that did not do what I wanted it to. The usual, it almost seems like the... so let's go find SCAD constants in our shortcuts, because that, it should have done something, and it did absolutely nothing. Which is like, what the heck? So it should have... Oh, it should paste a line. Paste line, this should, paste line, that should be a paste line. This should be a paste line. Okay, so if we type this, we're going to have a little prompt, and we'll make the date 2021-03-13 for this. And then we'll put that at the top of our shortcut file, which you cannot see, but just trust me, I have a shortcut file where all this stuff goes. And then we'll just type nfwcon for no framework constants, right? So, okay, and then these no framework constants, right? We have this shortcut here. Do you want to keep this kind of like linked list like this? I don't know, I guess. Or do we want to keep the indentation, right? In our OpenSCAD code, we kind of have this extra layer of padding always, which is like, I don't know if that was a good idea, but that's how we've been writing our OpenSCAD code. So, okay, so we got all this stuff, these good kind of constants here. The metagrid unit stuff, probably not going to be useful. I don't know yet. So, mug and air units that I usually use in my code, probably not useful here. They could be in the future. I don't know. I reserve the right to change my mind on that. So we need something that we can kind of bolt together, and we need it to kind of like how are we going to do this? We need some type of pattern that we can cut that's not going to waste too much material. I'm not sure what that's going to be. And it would be nice if we can keep it to, like, one kind of simple part, I think. Can we slide these into each other? Might be able to. Okay, here's what we're gonna do. We gotta start somewhere. And so I already have this design I really like. I don't know if it's the correct scale, but it looks good, right? It looks pretty cool, and so I'm gonna recreate it. It was actually a design that was just made for me bolting together a whole bunch of scrap material. So we're just gonna recreate that design. So we're just going to say module CHS component, and we'll call it Ori for original. It's the original design. And we'll just start hacking it out here. So we need like a, if we're going to make this, we need like a lug rect, and the lug rect is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's like 11. And it's 11 on the X, it's 1 on the Y. And then from that same location, we want to do another log rect that's the inverse, right? So 1 on the x, 11 on the y. And the other thing is that the origin, where's the origin? The origin of that's going to be centered, so let's just start with that. And that's not actually going to do anything yet, because we need the correct functions. So we'll also includes. So we need a section for includes, and we got to include kind of these standard functions that we usually use in our code. So, so let's do that. So we're going to include, it does not exist yet, but we're going to include a thing called functions. And let's not worry about the other things. Let's just worry about including functions. Let's get enough to work here. So paste underscore dot fun is what I called it, I believe. And yeah, scadfun 2020. Okay, so these functions are what I need, right? So now you could say, why not just include a library that has all these functions? The reason for that is they slowly evolve over time, and I don't want one change to some type of master function file to cascade into affecting all of my other projects in unknown ways, because I have like over 50 projects. I'd have to go into each one of them and manually check them all to make sure they're still okay if I'm going to leverage that kind of power, so I don't. So it may seem hackish that I do it this way, with this kind of snippet thing, but this is the real world, and sometimes things are ugly. Okay, so we included the functions, and let's go here. Let's just double-click this, and let's open it up. And, like, I don't think this is the best way to do things, the pattern that I'm about to make, but I think that we need to just get something working first, and then we can worry about other details. So syntax line 4. That's because this right here needs to be commentary. This needs to be like a big comment section. Right, because this is just a linked list. This is just a thing to help keep track of where I came from, basically. Okay, so then if we do like a reload and preview, F4 maybe? Yeah, there we go. So now we got this little X thing here, and not really much to see here. But we want to position it at the corner for now. So we want to go like, for this one that's on the X, we want to go like LX. We want to go like 0 plus, not quite 11. Well, let's do 0 plus 11 first, and then we'll fix it up as we go here. But that's going to put it at the tippity-tip, right? And then after we've moved it to the tippity-tip, we want to move it back so that it's centered on the middle of a 1 lug by 1 lug. So LX 0 minus 0.5. Let's call it 0.5. And then let's say P5 equals 0.5. Offset to tip. Inset to center of first 1 by 1 lug. Right? So it's like a pixel center kind of a thing here we're doing, if that makes any sense. This is kind of infuriating that this does not actually do anything, huh? F4. We gotta press F4 for this, huh? Okay. Yeah, so F4 to reload from the source file. So we see this is kind of offset more than we want it to be, and that's because the 11. So let's just say the BL for big len. BL equals big length, or like the longest length, whatever you want to call it, BL. So there's a BL here, there's a BL here, and this is going to be BL divided by 2. Okay, so if we do that, and then we do F4 over here, right, now that's kind of like where we want it. And let's just make sure, can't look at my thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so that is 11. And then over here, we want to take the exact, it's pretty much the same exact code. It's just that instead of X's, we have Y's, right? And then this command is going to be this command. And if we paste that in there, we go F4. We have this. Now, that's not actually where I wanted everything, because I was thinking in terms of a different type of origin. I really like things being in terms of top left. Maybe we should... Since this is the natural orientation, where everything's kind of in the positive, I guess maybe we should stick with that and change our mental model of what we're looking at here. Okay, so we now want some scaffolding that goes... looks like 1, 2, 3, 4. Yeah, 4 over. 1, 2, 3, 4. So we need to offset by 4. Okay. So we need like a little scaffolding, and we got to offset it by 4. So this is the outer L. So we'll just call this outer L. And then we're going to have like an inner L, I guess, right? Inner L? Yeah, inner L. That's exactly what we're going to have. Inner L. And it's going to be inset by 4. It's going to be smaller. So what we could do is we can make this easy. Let's just copy this, right? And we know it's going to be inset by 4. So we can do like a L, X, Y, and then just 4, 4. Because we know that that's the offset we're going to need on both axes. So we can just take it, copy, paste it. And then we can get this in the... we can get it in the correct position, right? So this is in the correct position, but it's not... It's too long now, right? It's because we need to reduce... We need to reduce the length by... We need to use a shorter length, right? So we have big length, and so let's do SL. SL equals short length. In the short length, if I look at my model that's in front of me, 1, 2, 3, 4, 5, 6, and 7. So the short length is 7. So let's take short length, 7, and then SL equals short length. Okay? And we don't use width or height because we have two different axes here, right, when we're making this. So then where we see BL in this code, we're just going to change it with SL. And then we'll probably need some other things, like this P5 offset thing here. Probably, well, no, that's probably okay, but... Okay, there we go. Actually, that is exactly what we want. Okay, so now that we have that, there's some more stuff we got to do. So we got the inner L, right? So the inner L is there, the outer L, and then after we have those L's, we want to cap things off. So let's just do... edge caps. The edge caps, I think, is the easiest thing to do. So let's tackle those now. And it is very slow to do stuff like this. Like, to draw this would be very quick. We're already be done, right? But the idea is to have some very tight precision with what we're doing here. So, if you look at this, look at our model. We got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, so the span of the bar span, BS equal, the bar span equals 5. So we'll just say BS is bar span. BS, bar span. Okay. And then we're just going to say LX for log rect X is going to be 5 by 1. And we'll have to change the origin of that, right? So we'll have to move it up by... so actually this needs to be log rect, my bad. And then we need to move it up, so LX 0 plus the long length. So we have BL, and then plus BL minus the 0.5 should be exactly what we need to do for the translation of this. Let's just keep this over here like this. And also, that's not going to be X. So this is X, so this needs to be Y. Save that, F4. Okay, so now that's in the correct vertical position. Or, ooh, is it in the correct vertical position, or is that not quite? Oh, because this is already centered here. So if we move it up, it's already overshot. So we actually want a -1 to get it correct. Okay. So now the next thing is we want to move it over, right? So we're going to do LX to move it over. And we want to move it over by the span. So we want to just say, right now it's centered there. We want to go BL plus 0 plus BL, right? The bar, actually no, bar span. I'm going to go bar span divided by 2, and then minus the 0.5, right? And then this thing, this 5 right here, should be the BS for the bar span, so BS. Okay, and then go over here, F4. And now that's kind of nicely kind of where it needs to be. So we can just duplicate this. We could mirror it, but I would rather just duplicate it and then just change the values, right? So the LYs and LXs, they get switched. And all the other calculations should be the same, and it'll just naturally kind of mirror where it needs to be, right? Not quite right, because the log rect, right, it's 1 comma BS. We got to flip the X and Y for that as well. And if we look at that, god damn it, I fixed one and then screwed up the other one. BS comma 1. Okay, so now if we go look at this, right, that's looking nice. So that's kind of the basic pattern I had. And from here we have like a little crossbar and some other details. We're gonna create like a little helper. So we're gonna do like a module CHS fixture. Call it a fixture. Sometimes I call it geometry or a subcomponent. Let's just call it fixture, and it's gonna be square nut, and it's just going to be a log rect. It's going to be difference. And we're going to do log rect 3 comma 3, right, on the outer. And then on the inner, we're going to do log rect 1 comma 1. And that's all it is. It's just a simple little shape. And then we're going to put this square nut in here. Right now, we'll just call it as is, and we'll worry about the exact placement after we get some feedback. Okay, so now if we look at this, and we do F4 to refresh, it's like not where I want it, but it's actually very close. So we actually just got to go LXY, and we just got to go 1 comma 1, and then it'll actually be exactly where we need it. That's kind of why I want to just kind of like do that first, so that we could be like, oh, yep, there, now it's in place. And then from here, we want a diagonal crossbar. So I want a diagonal crossbar. And you might be saying, like, why do I want all these kind of abstract shapes? Like, what is the goal here? And the goal is just recreating the kind of like weird abstract art that I have as a result of I have a whole bunch of scrap material, right? So sometimes when you cut a whole bunch of parts, the negative space sometimes will produce like very interesting designs. And one of those interesting designs, I'm like, hey, by coincidence, I can actually bolt this together. And so I bolted it together, and I got this really cool geometric abstract art kind of thing. And I want to... Now I want to actually cut this pattern itself and use it to create a design that's going to go inside the tabletop. So this diagonal crossbar, what we're going to do is we're going to do like a lug. Now, if we look at the design here, I'm going to guess this bar is probably maybe... Actually, no, it's not. Okay, so we're going to do a lug rect, and it's a diagonal, so I don't know exactly what the length of it needs to be, but we can just rough it out, right? We can say that as far as the leg of the triangle goes, not the hypotenuse, 1, 2, 3, 1, 2, 3. 1, 2, 3. It's like 3 lugs. So let's just try, you know, 3 lugs, 1 like that. Then let's rotate it by 45 degrees, so R4. And then when we go over here, it's going to be like right over here. It needs to be moved. Okay, what the hell? Seriously? Come on. What the effing hell here? Okay, let's comment this out for a second. Okay, so we had this, and then we put this back, and then we put this in, and then it just blew up in our face. Is that what happened? I have no clue what happened, but okay, so let's do LXY, and let's move it by 1, 2. We got to offset it by 2. Maybe 2.5 would be better. Let's start with 2. And see if that spans the entire distance we need it to span, or actually it might need to be, whatever. Let's just do this first. So LXY 2, 2. And let's try 4, 4 might make more sense. 3, 3 maybe? We're just gonna guess. Okay, so if we take that little guess, okay, cool. We got this little thing here. Okay, cool. So now the next thing is, what do we do now? Well, this design has a whole bunch of, like, heatsink patterns on it, but that also increases the surface area a lot. I don't know if that is going to be useful, or if it could result in more interesting reflections, I think. It definitely adds more implied lines, so I kind of like it. Anyways, let's, in these edge caps, I'm going to steal these 2 things here. And this bar span on the LX, we want to inset amount equals bar span minus 2. Ooh, or minus 4, I guess. Actually, I don't know. Oh, BL. Oh, you know what? Change my mind. We don't even need this. We just need to make this a 3, I think. There we go. Yeah, there we go. And then, we need to put a little crossbar. Inner edges. These are the outer edges. Okay. And then we need like a little crossbar thingy-mabobber. So, for that, we're going to just do an LX, or actually, we're going to do a lug rect. We're going to make it 3 by 1, or actually 1 by 3. We're going to make this vertical first. Or actually, we've done translation on the x. Let's just do it first, and then let's figure it out, right? So then on the x, lx, we have to move it over by, to center it properly, according to what I have here, 1, 2. I think we got to move it over by 2. So by 2. And let's save that. Let's go F4. It is annoying to press F4 every single time. So that looks like it's in the correct position there. And then we got to move it on the Y. So we have to say ly. I don't really know. I don't really care. 0 plus. I don't know. BL minus 3 or something. We'll figure it out. We'll just tweak it. I'm not gonna worry about exactly making this exactly perfectly parametric. I'm just going to kind of like wing it, right? So I guess that was supposed to be a minus 2, right? So that looks good to me, right? So then we'll just take this, duplicate it, right? So the y's become x's, x's become y's. And then the dimensions need to be flipped. And then we effectively have mirrored it over there, right? We've effectively rotated it. So that's the kind of pattern I want. It does kind of look kind of like, why? Why do you want that? You don't see the bigger picture. I do, because I have the model kind of in front of me. So no fault of your own. So we're going to call this... So original no, we're going to call this original no thorns, and then we're going to make a module chs com original with thorns. And we're getting abstract with our naming here because they're just abstract shapes. So sometimes when we give something a meaningful name, it's like it's complete nonsense because we really don't have a name. We just have, by nature of having kind of this abstract kind of art that we're making, we can't really give it kind of a sensible name, right? We just have to imagine things. So the little nubs that are on okay, so thorns are basically these external one-by-one kind of things on the design. So we're gonna take this and we're gonna put some nubs on here, right? So we're just gonna say these nubs. Basically, we can just make a lug rect, and we can do a one-by-one, and we can just throw that into there, right, and just see where that ends up. So this is, we gotta put this here though, right, and then we gotta go F4. So now we should have a nub. Oh no, because it's gonna be right there. I guess that makes sense. So this needs to be LX, LXY, 0 minus 0.5, 0 minus 0.5. Okay, and then if we go over here, F4. Okay, so it's a nub in the making. And then what we're going to do is we're going to do LX 0 plus 0.5 to move this over on the x-axis. F4, okay, that's in place. And then what we're going to do is we're going to do a grid clone X. And I forgot the exact parameters for grid clone X. So we're going to go in here and go find grid clone X. They might not be called grid clone X, it might be called something else, but I think it's GX. Oh, the number and the padding between the elements. So the number of elements, I have no clue. Let's just say 7, and then the padding is going to be in native units, so we have to say 1 times lug, looks like the spacing, or actually 2 lugs, right? Because there's a whole lug of empty space between them. So the offset should be this. Okay, so if we look at that, we have kind of this thing, and we're pretty close, right? We were 1 off, so this needs to be 6. And if you look at this, 1, 2, 3, 4, 5, 6. So that is correct. Okay, and then to get the pattern on the other sides, let's just mirror this, because I don't want to have to actually, no, because... No, let's just duplicate it. That's going to be the easiest thing, because our mirror operations are usually for like bilaterally symmetrical things, so the design of the mirror functions is not very conducive to what I want to do. So let's just do this on the Y. Let's change X's to Y's, right? And then lug rect that'll work. F4, there we go. We got this pattern over here, right? Okay, then over here, we need the same kind of stuff over here. So these are going to be the outer, we'll call this outer thorns. And why am I spelling thorns with a silent E? Because I don't know how to spell, that's the answer. Okay. So we got this, and looking at our design, okay. Let's make a section called Inner Thorns. And the Inner Thorns is going to be the same kind of design, but on the inner side. So you see the side that doesn't have any kind of stuff on it yet? That's where that's going. And then you probably also need cap thorns as well, right? So inner thorns, outer thorns, and then we also want like cap thorns. So cap thorns. And cap thorns. Okay, so the inner thorns, the first thing we can do is we can just do this. We can copy this, and then we can just do like a TXY. I forgot, like maybe 6 and 6 maybe? I don't know what the exact offset is, right? But first we can just offset it diagonally, and then eyeball it. And that didn't work because I did a TXY when I want to do a LXY for units. I used the wrong units for my translation there. So this is close. It looks like I was off by 1. It looks like I need like a 5, 5, right? And if you look at that, that looks about right. However, if we look at our design, right, this inner area isn't quite correct. So, with this grid clone, I think we need to move this by 1. I think we need to move this by, let's move it by 1, yeah. So if we move that by 1, we're a little bit better. 1.5 is actually probably going to get us where we want to be. 1.5 and 1.5. Okay, so if we look at that, that's actually what we want. And then 1, 2, 3, we're 3 over, right? So with this grid clone X, we're 3 over. So we just want these to be 3s rather than 6s. And then if we look at this again, we can see, hey, awesome shape. Okay. So now we want to get these little caps over here, right? So we know we're going to have like a grid clone on the X, and we know that we're going to have like some type of shape thingy-mabobber that's going to be it's going to be aligned with the other patterns we made. So 0 plus 0.5 is fine for this shape. to offset it, and then LXY, no, not LXY, the lug rect is 1 by 1. And we just want to get this working first. So let's go F4. And we can't even see it because it's probably this kind of line down here, right? So the next thing is we want to just move it up to where it needs to be its final kind of destination, right? So LY, we're going to move it up. And if we look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we got to move it up by 10, maybe by 11, maybe by 10.5. Right, but the idea is that we want to get close enough, and then if it isn't correct, we can fix it, right? So I'm not seeing anything, so that tells me I probably want to do 10.5 or even 11. We'll just overshoot it, and yeah, so we've overshot it. This actually needs to be like a 10.5, it looks like, and then it looks like we're offset wrong here. So I thought there was a 0.5 offset. It looks like I was completely wrong. Yeah, that's more correct. So now that we have this, we can take this, we can copy it, we can paste it, and once again, we can just, to mirror it, we can just change the x's. We can swap out x's for y's, right? And then that should be, this gx should be a gy now, and then if we do that, we should have the entire pattern, right? So that is what I'm looking at. I'm actually looking at an assembly of a whole bunch of these, but this is the basic thingy-mabobber that I'm looking at. So that's all good and whatnot. The next part is just, the next part is putting this somewhere where it makes sense. Like, I guess we'll keep this origin. Maybe it's not the best origin, but we really can't worry too much about the origin of things at the moment. So let's create some extrusions of these pieces. So let's do file new, and we're going to say new extrusions file, right? So a new extrusions file. I thought that would have worked. New ext file. Okay, so this is what we wanted. How about new extrusion file? Make it singular. Okay, so but extrusions doesn't work. New extrusions file. Okay, well that's fine. Next time we guess that, we'll have the correct answer. So I'm going to put that here. I'm going to put that in my notes. New extrusions file, new extrusions file. Okay, so it looks like we want to use something called scadtem.ext, probably scad template extrusions. And yeah, so this is a nice little template. And we only have one little thing right here. So we have this array of elements here to just give us an idea of the pattern that we want to use. And actually, we'll keep two of these. Because we're going to keep we have two functions. We got OWT, and then we have ONT. So let's close this. So OWT and ONT, right? So we know these are the names of the things. We want to keep the names really short just because it's going to make the code easier to work with, even though it can make it a lot more cryptic when we're trying to figure out what the heck our code does. And so this namespace here is CHS, right? The namespace of the current project we're in is CHS, so we're going to replace these kanji with the namespace, right? And then this thing right here, we're going to change that to CHS. And then the extrusion height is log times material thickness. We have the wrong material thickness on here, but we'll fix that when we get to it. So ext. Okay, so if we go to our material thickness, we're going to try this out of our acrylic. So our material thickness in terms of lugs is not 1 lug, because our lugs are 1/4 of an inch. And our material thickness is 1/8 of an inch, so in terms of lug, our material is 1/2 of a lug thick. Okay, so now that we have that, what we want to do is instead of this component, we want to change com for component. We want to change the subname space to ext for extrusion. And if we do that, we should have had some thickness, but we don't because F4, right? Ignoring unknown module, that's because we have to include the ext file that we just created. And then if we go F4, we should see something there. So now we got some thickness. Okay, so now that we have some thickness, we need to design the kind of thing I was working on. So it's kind of a spiral thingy mabobber, whatever. Let's not worry about exact offsets, right? Let's worry about like refactoring to exact offsets when we have something. Once we have something that's kind of working for us. So first of all, let's put an R0 in front of here because we're going to start duplicating some of these and rotating them into place, right? So this is going to be like R0. We'll make this like a R7, I guess. And then over here, we'll just F4 that for a second. And we want to move... actually, hold our horses here. Let's move this. So right now its origin is right here. We want to... so rotation, and then we want to do like LXY, 0 minus 7, 0 minus 7, something like that. I don't know. Take a guess. Let's not worry about it too hard right now. And then we know that eventually we want to mirror it radially. Or actually, well, yeah, let's mirror it radially right now, and then we'll get rid of the radial mirror once we see that everything kind of fits perfectly. So this offset, not enough. Let's put it to like 11, and then let's just rerun it and say, does that look correct? That's almost correct, but the offset is a little bit too much. So do this, F4, almost. Maybe it's a 9 offset. We'll just keep on keeping on here until everything overlaps in the way we know it should. So if I look at the stuff, that's actually the way it needs to work. But now I see that I have some excess details here. So I'm gonna comment this out for a second, and I'm gonna take the original with thorns really quick, and I'm gonna look at that because I see there's some excess details that I don't like, that don't look nice. They're not in the original design. And so this thing in the middle, right? So it's definitely subdivided, isn't it? I can't really tell with the bolts in. I can't actually tell. So I gotta unbolt this really quick. Yeah, with the bolts, it's there. Okay. So the crossbar in the middle here isn't really there. So when we're looking at the cap thorns, we really want to, instead of 2, we're gonna multiply this by 2. Yeah, by the time we do this, then it's like pointless. Right, so that's kind of the spacing we want. So instead of 3, we're just going to have 2. It's like, why even do it then? Why even... So here's what we want. We want a log x at 0, and it's a log rect 1, 1, right? We might as well just spell it out. So 1, and then we want 1 at... 2, 3, 4, 5. We want 1 at like 5 or something, right? So let's just get rid of this cloning stuff here, because let's unroll our loops, so to speak. And that looks better. Let's comment this whole thing out for a second because something's going on here. I don't know where this came from. Where did we change that? Did we change this down here earlier? Did we, like, tamper with that as well? Yeah, we did. Okay. So this right here, let's fix this first, right? So right here, almost, but this needs to be like a 4.5. Or actually, no, this just needs to be a 4. And if we do that, right? That looks correct. But then in the middle here, we need one more thing. So let's put a 2 in here, right? And that puts this thing here, but we don't actually want it to stick out that much, right? So, well, actually, hold on. Is it already subdivided? Did we already do that crossbar? Oh, yeah, so it just needs to be like that. Never mind. So that's all we need. And then for the other code, right, we just want to... This is ly, so this needs to be like a lx. This needs to be a ly, right? And if we do that, we get more... We get the pattern more correct to what I was envisioning, what I'm actually looking at. So for whatever reason, I like it like this in the middle. That stub in the middle just kind of looks overly cluttered. Okay, so now that we have this shape, we have yeah, it's because when we bolt it together, the reason is that when we bolt it together, oh god, let's just close this. I did not mean to try to render it, and trying to render what we have right now is just, we don't want that, because, come on. Yeah, trying to render this, just don't try to render it. It's three-dimensional geometry. All I want to see is this. I'm not trying to make an STL file. I'm trying to make vector cutting paths, but I want to envision how those vectors are going to go together. Okay, so that's the shape I want. So the next thing is, we know that they're spaced out correctly. So let's get rid of the rotational mirror, and we know that this is kind of correct where it needs to be. And then what we're going to do is we're going to do like a R0 here as well, right? And then we're going to do like a R0, and then we have like an R9, right? So this is an R9, and if we do those two, we'll have like half of it, or not. That's because... Oh, this is still an R0. These are all R0s in the middle, aren't they? It's just an unnecessary rotational parameter that we supplied. I'll guess we'll keep it for now. R9, R8, and R7, right? We don't really care what order it goes in. Okay, so there are those things again. But the reason we did this is so that we can change the height. So I'm going to get rid of these rotations here that aren't doing anything, because we're going to quickly run out of room here on this one-liner, and I would like not to run out of room if I can one-line this, because one-lining it, the reason I like having a one-liner is because I can see the patterns in the code a little bit easier between these different lines. So now what we want to do is we want to say odd-even. On the Z, we want to do like a +1, right? Or something, right? So a +1 or a plus whatever, right? So LZ, right? 1 0 1 0 1 0, right? Because they need to be staggered, because if we're going to bolt them together, if we need to bolt them together, the material can't intersect, right? So, right? Now, we got the offset wrong. Because we don't want to offset by that much. We want to offset by... First of all, let's go TZ. And then let's do M equals MMT, material thickness. Times... Actually, let's do times MMT. That'll be fine. Okay, now if we do that... oh, material thickness is in terms of lug, so it's still a lug offset, my bad. And so now these are offsetted, right? They're on top of each other, right? Now the colors make it kind of hard to see what we're looking at. So what we're going to do for that is the EXT values, we could give those colors, right? We could inject those with the color value. Or we could do it at the top level. I think at the top level might be easier. So I'll just let you do like a color and red. Right, okay, so now our one-liner is getting way too big, right? Our one-liner is out of control. So to fix that, to make it a little bit shorter, m equals MMT, right? So kind of shorten this a little bit. Or let's say m0 equals 0 times MMT, and then m1 equals 1 times MMT. And then in here, right, this formula here can be condensed, m1, and then m0, m1, m0, etc. And we're still too big here, but we've made some strides to shorten this. The rotation, that still needs to be there. We can remove some other lines. If we remove that line, yeah, we're still in trouble here. 0 minus 9, so we could say NN is 0 minus 9 for, just say N is 0 minus 9, and just say negative 9. And then this 0 minus 9, this can now be N and N, right? Okay, so now if we have that, the color module doesn't actually exist, so we have to paste the color module for this to work. So in here, we're going to do a new color module. And if SCAD, use SCAD temp color, right? So SCAD temp for template, and then a color. That's not actually what it's called. It's SCAD temp COL. So we're going to say SCAD temp color. So next time I make that mistake, I'll know what I'm doing wrong. I know what I'm doing wrong right now, but, you know, there could be times at which I've had less sleep. So okay. So all we gotta type is SCAD temp for SCAD template, COL for color, and then we have the color module. So pasted all this crazy color code, don't worry about what it does. It just makes it so that I can use kind of these preset color codes for making colors in the OpenSCAD code, which makes things a little bit easier for me. So we're going to include the color module. Okay, and then once we've done that, if we press F4, we should, bam, there we go. So now in the, let's close this. In the code here, right, we have this kind of crazy nonsense going on. Let's refactor this. This is an N, right? And then over here, we're going to say, let's just make it all red right now, and then we'll go in and we'll make like red, blue, red, blue, red, blue, right? And so this is going to be M0, M1, M0, etc. Stagger it. So if we do this, at some point we have, because we have, that's interesting. Oh, I see. So if we move that, okay, there we go. Okay, so now if we look at this, go F4, we can see, hey, everything's red. Still very hard to see things, but now we can do red, blue, right? Red versus blue. And now you can see how this kind of is going to go together. Okay, so we're going to put some bolts through here to bolt this scaffolding together, right? Now the thing is I have no clue if this is... I have no clue what the best design is for this. Like, I really like this, but we have to fit it within these bounds, right? So 5.25, we should start with like an inch bounds of 5.25. Let's create a thing here. A module CHS ASM. It's an assembly, and it's a final frame, final filler frame is what it is, really, right? It's this intricate pattern, scaffolding pattern, that's going to be embedded into the epoxy, which is going to save us. It's going to save us money on the epoxy, but at the same time make the table even more valuable because it's going to look awesome. Okay. So now with this, we just want to create inch bounds. I believe it's inch bounds like this. And we're going to do, if we look at our diagram here, we got 5.25 in the inner, right? So let's do 5.25 by 5.25. And no parameters in here, because we just want to see the actual bounds. And if we do that, we press F4, we can see, hey, you know what? That actually fits pretty well. Right? Like we can work with that, right? Because that pattern can fit just nicely, boom, right in the middle of the panels, right? Because 5.25 by 5.25, lucky coincidence for us, honestly. So we'll roll with that. And we'll kind of build off of that to create everything else, right? So we want to create some type of intricate pattern. So this filler thingy, we'll call this, we'll take this and go CHS ASM core. We'll call it the, we'll call it panel core, something like that. And so module CHS ASM panel core. Assembly just means we're taking a whole bunch of 3D components and we're assembling them in 3D space. So I don't mean assembly code like machine code. I just mean that we're trying to figure stuff out. Okay, so if we do F4, nothing's changed. But now that we have this, we can start moving things around, right? So if we look here, if the point to point from here to here is 6.5, then if we offset everything, then I believe the offset from here to here should also be 6.5. How can I prove that mathematically? Well, this edge right here, if we offset this some amount to get in the middle here, right? Then if we take this edge and offset it some amount to get in the middle here, it should be, that should work, right? So because, and then we'll be point to point here, right? Because we just, right? So all these points here you see are like equidistant. So yeah, I think 6.5 is the offset from point to the middle of everything. So if we say inch x or I don't know if we have an inch x, but let's just try 6.5 for a second and see if we have an inch x command or if we have to make one. We may or may not have one. Oh, we have one. Cool. So now that I know that I have that, I'm gonna say we're gonna do 0 here, and then over here we're gonna do negative and positive, right? So we'll do like 0 minus, 0 plus, and then just a 0, right? So if we take that and we run that, we should have kind of everything kind of spread out here. So you see there's this big gap here, and that's because if we look at the diagram, right, it's going to go right in the middle of these empty voids here, and then there's room for the frame. Okay. So now the next thing is just duplicating this, right? So we have this kind of thing here. And so on the x, right, so if we want to move it in inches on the x, we're going to go 0 minus 6.5, right, to move it up on the, or actually 0 plus 6.5. It's not graphical code, so so y at the top is actually a higher value. I always get that confused. And so we're going to just take this and we're going to duplicate it 3 times. And we could use a loop for this, but I'd rather just unroll the loop and make the code kind of as dead simple as possible. So, and this is going to be a minus, right? Because you can look at this and you can obviously see there's some type of obvious pattern. And that's what I want, right? I want so much redundancy that you can just tell, hey, there's some kind of obvious pattern going on here. Okay, so we could kind of like duplicate more things to get the final thickness, but what we really want is just to understand the layout of how everything bolts together. So we're not going to worry about that aspect. So this is already looking pretty cool, right? So The next thing is, we want everything to be connected, right? We want this one big... Oh, hey, sorry, I didn't... Yeah, so that's what I'm working on. I'm working on, this kind of pattern, this scaffolding pattern, we're going to make this scaffolding pattern. I still have some more connecting to do. But we're going to take this pattern, and where you see these little squares right here, we're going to bolt these together. We're going to bolt them together. We're going to make this intricate lattice work. And then what we're going to do, after we have this intricate lattice, is we're going to put this lattice on top of the table. So this is the top of the table, right? So we have this table, and we're going to make a unibody tabletop out of just like an epoxy pour. So we're going to pour like a giant slab of epoxy. We're going to put the lattice, we're going to put this lattice inside the epoxy, wait for the epoxy to cure, and then we're going to mill it down until it's nice and perfectly square, and then we're going to profit, I guess. We do need to be cognizant of the fact that there's going to be bolts sticking out here, right? So everywhere you see like a little circle, there's a bolt. And so if we want to be able to mill into this epoxy, we need to make sure that that we don't have any metal in the epoxy where these go. So we'll keep that in mind, or we'll just keep the epoxy deep enough. We'll figure it out. So where am I right now? Yeah, let's just keep on going here. Okay, so we got this kind of design. This looks pretty good. But we need to still connect this with some type of piece, right? And right now, we want to really concentrate on, hey, I need some type of filler, right? I'm trying to make some type of filler here. How are we going to connect all this together in a sensible way? So I'm thinking... I'm not sure how we're going to do this. I mean, we could try to connect these with these, right? We could just try to make some crossbars. We want to think about the visual density of the pattern. So this looks like a very airy kind of pattern, so we don't want to waste a lot of the acrylic we're cutting. So this pattern already looks very wasteful because it has a lot of negative space in it. The negative space looks nice, but if we're going to try to connect this with something, I feel like we should try to connect with something with less negative space. So... Uh-huh. I'd also like it to have enough ways to bolt it together where it doesn't shake apart on me. I'm not sure how I want to handle this. Okay, I'm going to look at my physical model for a second. I don't know. But I gotta think. I gotta figure out something. So we need some way to connect these other pieces, right? And right now I'm thinking just stacking this up in an alternating way to get this kind of like a heat sink looking pattern. And then we want to connect the heat sinks together. So the easiest way is just to take these little corner pieces and connect them together. But then it's going to pivot a lot. Well, actually, it won't if, oh, that's interesting. So in order to connect these in a way that helps us the best... Okay, let's go put the chat up here for a second. Okay. So we got something going here, but we got to think about these little modules and how they're organized, right? So these panel cores, every other one needs to be rotated 90 degrees. So first of all, let's put an R0 in here. Right? So we're gonna put an R0 in here just to get it started, right? In terms of the abstractions we're about to. So we're just gonna take this and we're gonna cut paste, cut paste, cut paste, put R0s in here, and then we're gonna fill them out with the correct rotations that we need. So okay, let's go F4. And nothing's gonna happen, no change. But then what we need is the direct one in the middle. We're going to rotate that 90 degrees. And then at the top, we want the ones on the end to be rotated 90 degrees. On the bottom, we want the ones on the ends to be rotated 90 degrees. Okay, so we take that, we save that, we go F4. And we're going to notice a change into where the red and the blue is, right? So you can see this blue is together, this red is together. This blue is together, that red is together. And that is going to make it easier for us to connect things. All right? So now that we can connect this a little bit better, it's going to make it easier for us to create some type of scaffolding we can kind of bolt together here. So I'm thinking, One thing is maybe we want to change this around a little bit. Maybe we want on the interior sides, maybe we want some type of pattern where these little edges here can be used to bolt things together for a scaffolding, and only the interior ones, right? So we can, the exterior ones we don't have to, but like on one half. So if we look at one half of this, so we'll make different panel cores for, yeah, I think that's going to be the best way to do this. So so can we do some with, is that going to work everywhere? Well, this one here, this one on this edge here, we're going to want this kind of pattern here, but we're not going to want, we're going to want the, like, little rings here, but we're not going to want them there, right? So this is going to get a little tricky. So what we're going to do to make this easier is, this is going to be panel core 1, panel core 2, panel core 3, 4, 5, all the way to 9, right? And so this thing is going to be called panel core 1, right? So PC1 equals panel core 01. Okay. And we're going to take these panel cores, right? We're going to go bam, 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 and bam, right? We're going to throw these in here. Okay. And then we're going to, because we're about to get really crazy with this, first of all, we're going to take this code and put it into assembly file. So we're going to save this, and we're going to save this as .asm. ASM for assembling things in three-dimensional space, not for assembly code. We're going to include it, right? So we're going to include it after the extrusions. Okay. And then we're going to go F4. Okay, so now that we have this, we're ready to... So this is going to be PC... this is the top, so 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We're gonna get those into place. We're gonna do F4, it's gonna crash on us because only one of those exists. We're gonna go in here, right? And we're just going to go paste this a whole bunch of times. So let's make a FARC template, right? And let's, because a lot of this is just going to be used over and over again, let's just kind of one-line these. Like that, I guess. And then let's take this code here. Let's put it in the source. Let's look for PC1. And we're going to replace it with PC2, PC3, 4, 5, 6, 7, 8, 9, right? So 3, 4, 5, 6, 7, 8, and 9. So we'll take this, we'll go FARC, and we'll run it. And we just have this cut and paste code, right? So we're stubbing everything in so that we can start to modify it in a way that's desirable to us. So right now it might look kind of pointless because there's a whole bunch of redundant cut and paste code, but there is a point to what we're doing here. Because we need small little edits to make this kind of nice. Okay, so now that we have this, the next thing we want to do is start to get like little rings in these cross sections so that we can start to bolt it together, right? So we can take all these modules and we can kind of cross stitch them together, and hopefully awesome stuff will transcribe from that, or transpire. Okay, so this OWT thing, we want another thing called like OWT with rings. So let's go take the OWT. Let's go find where OWT is coming from here. So OWT, right? So we're going to say original with thorns, right? So we're going to go module chs com OWR OWR original with rings, right? So this one's going to help us bolt it together, right? So we're going to call this from within it, and then we're going to add rings to it. Before we do anything more, though, let's put a breakpoint here, and this is the thing we're working on. But let's comment that out for a second so that we can focus on. We really want to focus on this OWR thing, right? So the OWR thing, let's focus on that right now. And start adding those rings where they need to be. So right, we want rings on the edges. Let's not make two functions for this. Let's make a function where you can put rings on this side, rings on that side, right? So, let's do rings on left. We want rings on left, rings on right, rings on both. So left, right, and both is actually what we want. And so this thing, I changed my name on the name, right? So, rings on left, right, or both, LRB. Right, so we're going to make a little section here. And we're going to put the different functions for this, right? So we want left, right, and both, given the default position, right? So I guess it's more like left, bottom, and both. But let's just call it left and right, where if we're like dividing on this divider line, that there's left is up here, right? And then right is down here, and then both is B, right? Instead of B for bottom, right? So B, left rings has left rings. Okay. R has right rings. And then B has both left and right rings. Okay. So these are rings that are going to help us bolt together what we're working on. And so we're going to take this and cut and paste it a few times, right? So we got left, we got right, we got both, right? So if we take that, we try to run it right now. We have 4 overlapping calls. That's fine for now. But we want to comment this out and work on the left. So let's work on the left side, and then we'll work on the other sides as we go. So rings on left. Okay, well, I mean, the first thing we want to do is just create like a, we have like a little square knot pattern thing, right? And we actually just want to use that a whole bunch of times. So if we do that and just throw that in there really quick, it's going to be right at this corner here. And then we just want to offset it. So we do like a LXY, and we go, I don't know, 0 minus 1, 0 plus 1, something like that. I don't know if that'll work, right? But we're just going to eyeball it. I think that is, yeah, that's correct. Okay, cool. So then the next thing is we're just going to do like a GY, and the number of clones is going to be like maybe 4 or 5. And then the space between them is going to be like either 3 or 6, or I'm thinking it's going to be 3 plus 3 is 6, and then a minus 1 because there's an overlap. So I think the spacing is going to be 5 times log. I could be wrong. I'm just kind of trying to do the math in my head here. And if we give that a shot, we are totally wrong. Let's change that to 3. Oh yeah, so I was totally wrong. It's more like 3 minus a 1. So F4, my math was totally wrong. I was totally wrong with my math. So that looks all right. The question is, do we want like a little fringe off of here? Would it look more consistent if we put a little nib right over here and a little nib right over here? I think it kind of would. Part of me thinks it would look a little bit more consistent with. I don't know. Let's not worry about that aspect, right? Let's see how it looks first, and then we'll judge. Okay, so we got that. That's done, right? So now what we want to do is we want to take this one here, and we want to comment it out. Right? We want to comment it out, and we want to work on the right side. So here's the right side version that we need to work on. No changes to it yet. So we want to go in here, and we want to take this code that we wrote. We want to paste it in here. Try to keep the code kind of similar structure. The GY is now going to be a GX, right? This is a -1, +1, so this should now just be a +1 and a -1, right? So flip everything around. And if we do that, we go F4, we should see something down there, right? And that is exactly what we have. That looks awesome. So now the next thing is we want one with both, right? So the one with both should be pretty dead simple, right? We just got to take the code we already wrote, and we have to just paste it into both, right? Now, so let's go F4, right? So we have this kind of pattern here, and we want to take this. So we want to take the GY, and we want to take the GX as well. So if we take this, I don't know what order it matters. Let's just take both of them. Let's not worry about the exact order. It doesn't really matter. So yeah, save that. Go over here, F4, and now you have this, right? Now this is a pretty bulky boy, right? It's like, whoa, it's a little intense, but it's all for a good cause. So we're gonna comment this out, and we're gonna comment back in kind of the thing we're working on here, right? It's this thing here, right? So we're gonna take it. Okay, so we got this kind of array, right? And it's pretty good. It's a pretty good kind of basic, interesting kind of pattern kind of thing. But we need more. We need better. We need to do better. We can do better, people. So we know that we have the rings on left, rings on right, etc. thing. So if we look at here, we can tell what's red, blue, and etc. Right? I think it's going to be easier if we have RGB and then I don't know, RGBC, all right, cyan, blue and cyan. It doesn't really matter. We just need to make these colors different so that we know exactly. I just want to know exactly what I'm looking at when I'm about to add the code to it, right? So actually, change my mind here, but yeah, I changed my mind. You know what? Let's do this. We're gonna have red, blue, or actually we're gonna have red and orange, and then we're gonna have red and orange darker, right? And so we're gonna just look at that first one and see if the coloring is satisfactory. So we got red and orange, and then we have red and those colors look too similar. So I'm going to say red and green, red and green. So if you do that, we just want to be able to tell the difference, right? So we have dark red and so the reason why I want this is because the reds are on the top. You know what? Let's do blues. Okay. Blues are on bottom, and the reds are on top. Now, with a light blue and dark blue, I can't really tell the difference, so I'm thinking a cyan, a light cyan and a dark cyan rather than a blue, just so that we can see the difference, right? So these ones are on the bottom, right? The bluish cyan, the cyan color. Actually, we could use a sky color. Let's use sky, right? So let's use sky. So, because cyan is not really blue, so there. So we have the sky blue. We can tell the difference between these blues a little bit better, the light and dark versions of them. And so the blues are on the bottom, the reds are on the top, right? So that way we can kind of see what we're looking. We can see what we're looking at. Kind but we also can visualize what's on the top and what's on the bottom very easily. So now that we have that, we're going to go in here, we're just going to column select, and we're going to kind of redundantly kind of like go through here and just be like paste, 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 until everything is using this color scheme. Very redundant, I know, it's there's a lot of repetitiveness in this. But now everything is using this color scheme. It's going to be really easy to go through here and change things to the correct things, right? So if we look at this first one, right, PC1 is the first cell up here, right? We're using scanline order. And what was the naming convention? RO and then LR and B, right? So it's this dark cyan, this dark sky color is the lowercase, right? And so we want RO and I guess that is L, I believe. I think. I'm not sure. Let's see if we got it right. Oh, so that didn't work because we have no extrusion file. We have no extrusion function for that yet. So we're going to take this, and we got to say paste this, and we have to create a thing called ROL, and this component is going to be ROL as well. So ROL. So we create an extrusion from the component, right? So we create a 3D version of the two-dimensional cutting path. So we have left, we have right, and we have both. So LRB, and then LRB over here. Okay, save that, go F4, and take a look at what that looks like. So now, I can see I totally screwed that up. This was the dark color. That's fine. No problem, we can close this, and we can try again. So this thing is the dark, OWT. We wanted to focus on the light, so what was the name again? It was ROL. So it's either going to be correct or it's not going to be correct, and if it's not correct, we just have to change which one it is. Okay, so now the light red, so the capital R for light red, should be the opposite, so it should be ROL, or ROR. Really? Did I make a thing called ROR? Oh, yep, that is what it's called. Okay, so if we do that, we got this. But you know what? It actually needs to be both because it's in this intersection where we're going to put this kind of... We're going to create some type of weird scaffolding thing that's going to connect these all together. Okay, so now that we have that, we have to look at the dark cyan. So this dark cyan actually needs to have like a... ROL, I think? No, ROR, I think. Oh, no, yep, there we go. And so now we have kind of this scaffolding that's going to help us connect this one to this one, right? So that's the reason why this kind of weird scaffolding is here. And the other thing is cool is when we bolt this together, the scaffolding is not going to exist on the path where these bolts are going to be in the original frame. So that's going to be nice. Okay, so now that we have that, we just gotta have to keep on doing that to all this other stuff, right? So we know that on a lot of this, we're gonna have both in the light versions right here are gonna be both, right? So first of all, I'm kind of confused why we have things in sets of 4s. Oh, so this is PC2, right? So PC2 right here. This is PC2. And the light versions. Hey, how's it going? Yeah, go ahead. Ask your slightly off-topic question, and I know that... NFT art. Okay, yeah, let me take a look. Oh, are we talking about the, oh, we're talking about the cryptography art where it's like it's somehow like embedded into the blockchain or some crazy batshit stuff. I don't know. That's what I think. Okay. Yeah, so, like, I can't, yeah, my stream sucks, so... Maybe. Yeah, I don't know. Well, I don't want to create any... I don't want to get into that... I got too many side projects to try to, like, make some weird digital cryptography GIFs, right? Because I got my code base, I got my rendering engine code base, and then I have this. That's enough for me to do, right? Because I want to do, like, a decent chunk of work for each of these every day. But yeah, I'm trying to take this frame, right? I got this table frame, right? And I'm going to make a monolithic slab to go on the top here. And epoxy is very expensive, so what we're going to do is we're going to embed the epoxy with a weird lattice work that is going to displace some of the epoxy and reduce our material cost while at the same time making the table cheaper. Which I don't know if you heard any of that because my bitrate sucks. Yeah. Yeah. So yeah, that's what I'm doing. Yeah. So, yeah. So I'm working on this scaffolding, and right now, right. So the scaffolding, we're gonna make like a heat sink pattern, right? So, we have these different layers. We have odd and even layers. We're gonna bolt them together, and then each one of these little modules, we need to cross-link them together, right? We need the final lattice work to be kind of this mono-bodied thing. So we're looking at this panel right now, and we're changing it around a little bit to give it the correct connector pieces. So if we look at the light red, this is the light red right here, and we know that we need connectors on both. So we're going to go ROB for both, and then the light sky blue also needs connectors on both, so ROB, right? And then this one this stuff here is either left or right, so we'll just do ROL and RO like this. We'll take a guess, and then if our guess is wrong, we'll just flip it around, right? So that was actually the correct guess. So we can move on to the next one. So here's the next one. And I will check chat after this. So this one right here, we have this right here, which is going to be both. So the dark is going to be ROB for both. The light red is also a both. So if we do, actually the light red is not both, it is, it is a, I don't know, let's just do ROL. And then, let's just do ROL and RO, whatever, let's just do that. Let's just take some guesses, And if they're not right, we can flip them around. So this is correct. The light red is not wrong. That needs to be a both. And then the dark ones need to be inverted. So this one needs to be... oh no, the dark red needs to be inverted. So this needs to be an R. And the cyan color needs to be an L, I think. So let's change that. Let's go F4. And let's take a look at that. Okay, so there we go. Actually, I'm wrong there because we don't have any connectors on this side. So the red, I'm wrong there. This needs to be like a ROR maybe. And I'm wrong, so that needs to be an L. I'm just gonna guess for now. So it looks like that's the left side. This is the left side right here. Okay, and then on the light cyan right here, this is not an L. It's gonna be an... it's gonna be none. It's gonna be just the OWT thing. My bad. OWT. So if you look at that, F4. So we got connectors here, and then we got connectors here, but we don't have connectors on the edge. So that looks good. So we got those first three done. I'm gonna check the chat. Don't forget to add tags to your stream to help people discover it. Oh shit. Let's do that. I have no clue. Okay, tags. Here's tags. Well, we got these tags. English programming, ask me anything. Design. Technically, I am doing design. Fabrication. I'm gonna guess fabrication is not a thing. Let's throw in just chatting. Let's just throw it in. Come on. I mean, if the oh no, oh chatting. How about sculpture? Could we call it a sculpture? Or is sculpture stretching it? Okay, so let's go back in here and let's kind of like tackle this one now. Right, so we got 1, 2, and 3 are done. So PC4 right here. We know that this one's not going to have any changes, and this this one has a change. It has a change on the left. So this is going to be ROL, and then this one. Oh, that's not ROL. That's RO. I don't even know. Oh, this is ROR because it's red. The cyan is RO. This is the dark sky blue. That's the left. The dark red is on both, right? So that is ROB, and the dark cyan. Oops, the dark cyan is the RO. Is the ROR, right? This one is the light version. This is the light version, and the light version is actually on both, which means this red is not both. This red is like on the right. Oh god, I obviously got this wrong. Just because I'm looking at the color codes and I'm like, I don't know what I'm looking at. The red is definitely on both. So the dark red is on both. Okay, and then the dark bluish is the wrong direction. So if we take that, there we go. So we can connect from here, and then we can cross-connect here, and we can cross-connect here. Okay, cool. So now the next thing is going over here and doing the same thing, but the one in the very center, PC5, is pretty easy, right? It's just ROB, both. It's both on all of them. Go F4, and then bam! Done with that one. That one is easy. Now, I think sculpture is fine. It will be a physical manifestation then. Okay, let's go. You can only select up to 5 tags at a time. Technically, we're not doing level design at the moment. So, let's do sculpture. And let's hit done. Okay, so we got all the tags. We used 100% of the tags. Let's keep on going here. So over here, most of these are going to be all the way connectors, right, in the middle. So I think the easiest way to address this, to get this kind of working here, is within the code, we can just, first of all, we can just make these all the ways. And then we can change them, we can change them to our needs on the edges, right? So the dark red, the dark colors need to be changed, right? So these dark colors here, it's going to be like maybe a left and a right, or a right and a left. It's going to be one of those or the other. Let's just throw something in there, and 50-50 chance. Okay, so first of all, not the colors I'm looking at. Dark red is right here. And then that's the light cyan. Okay, so let's get that working. And then after this, okay, you know what? Screw these colors. These colors are annoying the hell out of me. So obviously these colors don't look quite, they look too similar. So we're gonna, first of all, holy crap, the S's look too alike. That's our first problem. So RG and O and L. Let's try that. Oh, lime, right? So if we try that, okay, that's a little bit easier to look at, to visualize. Except for the orange is not doing it for me. So let's just say, actually, we can tell the difference between the red, the light red, and the dark red. That's fine. It's just the green colors that are messing with us. Okay. So now, with this red, the red needs to have... Oh, the red is both. Oh no, the red is not both. The red is on the right. And then the lime would be on the left. Like that. Okay, let's go F4. Take a look at that, see if those connectors are... Okay, am I just stupid? Do I just not know what the hell I'm doing here? Like, I'm getting really frustrated. Lime. This is a dark lime. Oh, this is actually green. Lime, let's just use yellow, right? Let's use yellow for a second. Okay. Let's just use yellow. And if we use yellow, yeah, I can't even tell what colors I'm looking at, so I keep on getting this wrong. So yellow is both. The red is good. The dark red is wrong again. The dark red is right. The green here needs to be left. Okay. It's like, geez, I just... you know, guessing would have been better results here. Okay, so there we go. We got that right there. Let's check the chat. Okay. So, let's move on to the next one. Let's move on to this one. So, instead of PC6, we're at PC7. Red, green, blue, and cyan, because I just do not want to have trouble with these colors when I'm looking at them. Okay. So, the green and the red... The green is the only one that's going to be both, right? So the green is the only one that's going to be ROB, right? That's the only one that's both. The red is... the red is the right... Yeah, the red is the right color. So we look at the red. That's ROR. Okay, the blue... is the blue is the left, Why'd I have both there? Didn't we say that was the red? The blue is that. The red is that. Okay, the green is the one that was both. So, okay, and the cyan is none of them. So, okay, let's take a look at that, see if we got that correct. Okay, that is better. That's better than the last time we were taking guesses. So I think that it helps to have like a color scheme that makes it easy for us to look at things, right? Okay, so let's look at number 8. So number 8, in here, we need to say the blue is going to be the always, right? So the blue and the cyan both are always, right? So blue and cyan get the always treatment, so ROB for both ways, right? And then for the other ones, we just gotta figure out which one's right, which one's left, right? So this one right down here is the right. So if green is right, then the other one's left. So ROL, and then this one is going to be ROR, if I can find my cursor. ROR, okay. So let's look at that, F4. And we got that completely the wrong way, but the cool thing is we know they're the inverse of each other, so we just got to flip those and boom. Okay, so the last one, let's take these colors, because these colors are making it easy for us to figure things out. And then also let's use like, I don't know, let's not worry about that just yet. What color do we use on the top here? Yeah, the cyan thing not working out for us. Okay, so over here, the blue is the only one that's all way. So we go find that blue, and we go ROB for both ways. Okay. And then the cyan and the green are the only ones that need to be changed now. So cyan and green, I don't know, let's just guess ROL and ROR, right? And then if those are wrong, we just flip them around and we're good, right? So if we got that wrong, which we did, we just go change it, right? And now we have everything kind of laid out how we want it, right? So we have this kind of weird scaffolding kind of pattern for this intricate kind of pattern in the middle. And then we will we'll start to we'll now make some connectors bridging these little gaps here. So how are we going to do that? Well, before we even do that, let's do RG and RG, I guess. I like blue on bottom, but it's hard to tell the difference between dark blue and light blue, so green is easier to tell here. So we'll just change all these colors back to make them more uniform, because we were just changing the colors so that we could understand what we're doing. We're going to use RNG because we can, red and blue, too hard to see the difference, because the brightness range of blue is like more clamped than it is for red and green, because it's a very cool color. Okay, cool. So that's all there. And we see that we can start, if we visualize this, we can start lacing these together. We can lace these together, right? And then we can lace this together, and then we can lace this together. So visually, that all looks correct to me. So we're thinking, okay, that's going to go in the middle of the table, right? And so it's going to fit right in the middle here, and we're going to lace it together, and then we'll have a decent amount of trim on the edges. And right, having that trim on the edges might be good, just so that we don't accidentally screw anything up. Or we could try to make the scaffolding to the exact specifications of if we make the scaffolding, well, if we do that, then we don't have any of these, right? It's just, we just change the pattern, don't we? Yeah, I mean, that might be better, though, because right now this is kind of like in the middle. And if we make the scaffolding go all the way to the exact edge, the advantage of that is that we can start to trim it down, right? So we can make we can overshoot the scaffolding a bit, so that when we mill it down, when we make the frame for it, when we make the mold, we can put this scaffolding into the mold, and if it fits perfectly into the mold, then we are confident the mold is of the correct size because we bolted all this stuff together and all that good stuff. So I'm thinking that this right here, so all that work we did trying to figure out which one of these things to use. We did a whole bunch of work trying to figure out which one of these to use, and now we're like, you know what? Never mind. So you know what we're going to do? We're going to... Well, first of all, let's make some shorthand functions. Or shorthand wrappers. And let's take these things that matter to us. Right? So let's do like a module... And that's going to yield this, right? And then we have ROL left, RO right, and then we have RO both, right? Do we want to say EXT? Let's say E. Let's do E for EXT, right? And let's say this as SH for shorthand. And then in here, in our main file here, we're just going to, before the assembly, we're going to say include shorthand. Shorthand. Okay, so we haven't used them yet, but the idea is, the reason we're going to do this is so that we can shorten this a little bit, right? So we can just call this can be called E, right? And then we can give this a E underscore. And then I'm going to check my chat, but I want to just finish this thought before I check chat. So we're going to change all these to these shorthands so that we can do... so we can add a piece of commentary. So if we change our mind, because we did all this work, and it's like, this sucks, we did all this work, but let's make this shorthand so that we can keep a note of the work we did in case, for some reason, we decide to revert backwards later. Right, so hackish version control, right? So F4, if we run that, we should still see all the same stuff, right? And let me check chat. Anyone in here? Nope. Just what Z said earlier. Okay, so now that we have this, it's time to... We just want to take the commentary that we have in here, and let's just kind of remove some of this extra space, right? Right, so remove the extra space. We don't need all that extra space. And we're going to just select, we're going to column select all these calls right here. And then we're going to put it in the commentary over here, right? So we're just going to go right here like this. And then we're going to, ooh, not like that. We're going to try that again. So column select, right? So we're going to column select, copy, and then we got to column select, paste. Right? And if we do that correctly, yeah, that's correct. Now we got a little bit of excess tokens that we don't need, so we can kind of clean that up. Or actually this neg needs to be cleaned up as well. Right, but now we just have these commentaries so that we know what it was originally, right? It's very packed, but now, because now we're like, you know what? Never mind what we did right here. I changed my mind. So let's now go in here and just change everything to OWT, right? So we decided that, actually, no, ROB. Everything's going to be changed to ROB, right? So ROB, 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 ROB. And some of the design considerations aren't for what is most aesthetically pleasing, but for what is just going to make it easier to make this, right? So, okay, cool. So we got this kind of pattern, and for this lattice work here, we're going to bolt all the lattice work together. Holy crap, that's going to get heavy. But this could get pretty awesome. I have some good feelings about what's going on here. So I need to take a break. Relatively quick break. I'm gonna like heat up my hot chocolate, and then we're gonna work on the lattice structure that needs to go into the middle here, right? Also on these edges, I don't know if I really like the edge design here. I think that what we could do, like, this edge design is going to be taking a lot of, going to take a lot of bolts. So I'm thinking we got to fill up these edges so that it's like every other. Or not every other, we could do minus, okay, this, not this, not this, not this, not this. Okay, yeah, actually if we did every other, that would actually work out pretty well. Because then we fill these two things here, and then bam, it just works. So what we're going to do to fix that is, let's address that issue right now. Now, we could just keep it like that. We keep it like that, and we just don't put holes through it, right? But I would like this to be, first of all, more holes means more laser cutting time. Okay, that's the first thing. Also, this just looks like too many holes. I don't know. I would like this to appear more solid, right? These edges appear more solid, so we have this lack of density here. So I'd like to get more dense over here, right? So in order to do that, I'm thinking, let's just go find the RO both, right? So RO both. And RO both. And we got this thing called square nut. And we're just going to hack this together. We're going to hack this together and say, let's put a breakpoint here first. And let's comment this out. Let's just focus on the both for a second. Okay. And we're just going to say, for the both thingy-mabobber, we're going to fill excess edge holes. So we're going to fill the excess edge holes because right now we have too many holes. It's going to take a long time to drill those, and then it also lacks a level of it's too noisy. The pattern is too noisy. It has too much visual contrast. Fill excess edge holes. Which one did I spell wrong here? Oh, that one, obviously. Okay. So for this, we're just going to say we want a lug rect that is... Technically, we just need something that's like, 3 by 3, but we could make it 2.5, we could make it 1.5 by 1.5 or 1.2 by 1.2, just enough to fill the area that we're working with, right? And we can see it right there hiding on us. And we're going to move it 1, 2, 3. We're going to move it 3 up. So we're going to do like LY 0, let's just make it a 3, right? We're going to move it up 3. And then on the X, we're going to move a whole bunch of stuff up on the X. So we're going to just do LX 0 minus 1. And then we're going to F4 this, and we want to see that hole filled, right? And then we want to duplicate this, and then this one, we're going to move it up more. We're going to go 5, and look at that. And then, not 5, I guess, 6, 7, can't do math. Okay, there. So now we got these holes kind of filled. All right, so we have kind of less dense and denser, right? And then we want to take this pattern here, and we want to just do the same thing on the other edge, right? So we just swap the X's and Y's. So this is going to be Y, and then this is going to be X's. And I think that's all we need to do. Let's just run it and see if that works. Yeah, that looks good. So yeah, that looks good. That looks actually much better because the visual density just looks a little bit better. So now let's take that and let's see if we like that. We have to remember that this isn't going to be the final thing. There's going to be more details that are layered on. So let's give that a look and see what we got here. Let's see what we got. Let's see what that looks like. Okay. So that looks pretty cool. And so we want to connect scaffolding between these points, right? Now the scaffolding itself that we're about to bolt on, we could make that a little less dense, right? We could make it like a continuous like stripe pattern, right? We could just do that. I'm thinking we make it stripe in here, and then it like has a 45-degree cut on it, right? So that we can bolt this together with a connector, bolt this together with a connector, etc., etc. I think that would look pretty awesome. So I think that's how we'll do it. So I guess we need to make the connector piece now, right? So we got this kind of thing here, and we need to make the connector, right? So we need to say so first of all, these components, we're going to steal all these components and put them into a components folder. Or not a components folder, but we're going to put them in a components file. So all this stuff here is going to go into a thing called components. So we're going to steal all this and go File, New, and we're going to paste this here. We're going to save this. It's not going to work anymore because those functions are missing. And then we're going to save this as _.com for components. Save it. And that's still not going to work because we have to include it, right? So we got to go in here, and we have to go include it. So we want to include it before the, it's a component, so this is kind of where it needs to be included if we think of, standard C ordering without forward declarations. So this is components. Okay, and now let's go F4, see if that runs. Okay, good. And the next thing we want to do is we want to label what the heck this is, right? So these are the inner components, right? So since we already have this kind of this padding, we can just say, you know, inner component, inner core components, right? So we can make like a little heavy-duty kind of line here. Like that. And then we can repeat the same thing at the bottom, right? So we can go down here. We can paste that. We can flip this around. We can put this over on this side. So we got these inner core components. And then we want connector ladder components. So we're going to call it a connector ladder. I don't know what to call it. This is all very abstract, so the names don't really matter that much as long as they kind of make sense to me. But we'll just call it a connector ladder because that's the best kind of name I have for it. So we'll paste this over here, make this section divider, and there you go. So we got the connector ladder section, we got the inner core section. And so now we're ready to write some more code for this. Let's check our chat. Nobody's chatting with us. So now let's create that little lattice thing. Like, well, first of all, what the heck is the spacing here? Like, I have no clue what the spacing here is, you know? So first of all, this lattice needs to... We want to remove this nub here because we want to remove this outer nub because it's going to be easier to get everything flatly over here. I don't know. We'll think about it as we're doing this. But I need to take a break. So we'll keep on working on this lattice. But I gotta take a break. And then, oh god, is it all 8:01? God damn. Okay, I gotta do some push-ups as well. So I'm gonna take a 20-minute break, and whatever time that I have left over after my quick break, I'm gonna do push-ups and stuff. I don't know why a Sunday reminder. Okay. Okay, I'm eating a tangerine, and then I'm gonna get back to work. But I'm gonna eat this tangerine first. So. Okay, let's just close this, and let's look at what we need to do here. So we need to create some type of connector, and the connector, because of how this is connected here, the connector can really only span here and here, maybe. So I'm thinking we make some type of flat-ish connector that kind of just is just this big square that kind of like connects these two pieces, right? So it kind of lines up nicely. And if we wanted to, we could also kind of fill this gap here, but I'm thinking let's just focus on kind of patterns that are going to not waste too much material when we try to cut them. So my thought here is that we want to think about how much material we want to think about making some type of connector that will I'm thinking we make these pieces out of black acrylic, and then the connector could actually slide slide in here and color these little negative spaces. And if we do that, then we can also fill in these negative spaces with different colors, right? So we could make this like a we could make this black and blue alternating, right? And we can make it a checkerboard, right? So this could be 1, 2, 3, 4, 5. 1, 2, 3, 4. It wouldn't quite work out evenly though. But we could try. No, let's not try to fill in with the wasted material. But let's. I mean, that could be useful. Let's put this over here. It could be useful to fill that part in. Right? The more space we can use up, the better here. So I'm thinking, you know, we make it out of black, and then we fill it with, like, clear or blue acrylic. I don't really know. I don't know what color would look the best. I'm thinking that the frame part being kind of like a black and then like having blue in the middle could kind of look nice. Especially because the blue is going to start to meld with the epoxy pour, which is also going to have some blue color to it. Okay. So let's just try to create the basic shape that's going to connect these four. And then from there we can work on connecting everything else together, right? Yeah, okay. Yeah, so let's do that. Something in, if we're lucky, the spacing between here is an even number of lugs, but it might not be. Let's just stick with whatever spacing we have here. And let's create a connector. So in here, we're just going to create like a module CHS com, and it's just going to be con for connector, right? Or lad for ladder. Let's just call it con for connector. Okay. And the connector, we're just going to try like a lug rect. That's going to be 5 by 6 maybe, 5 by 6, 5 by 7. Okay. And then let's do a union difference. Okay. UDI to X64. Right. So we got this pattern for kind of like creating the additive geometry and the subtractive geometry. So this is the additive geometry. The subtractive geometry we want is kind of like a 1x1 lug rect in different locations. So the first location we're thinking is like LX 0 minus maybe 1.5. And then 0 plus maybe 2.5. I don't know. I'm taking guesses here. And let's just do OSX equals 1.5. And then let's do OSY equals 2.5 so that we can change this later if we figure out that we're totally wrong here, right? So OSX, right? And then OSY. For offset X and Y, and then we're just going to duplicate this, right? So we're just going to go, okay, X, and then let's just duplicate this a few more times, and we're just going to change the signs on things, right? So let's just do negatives. Let's do negatives. Let's do positives. Let's do the negative positive and the positive negative. Right, so that we hit all those quadrants where we think they're going to be. And like I said, it might not be correct, but we're just going to give it a shot, right? So the next thing we want to do is we want to add this module into our extrusions. So in our extrusions, we have all these extrusions. We're just going to duplicate one of these lines. And we know that we have this thing called connector, right? So CON for connector. We have an extrusion for the connector part using the connector component. So here's the connector component. And then here's the extrusion of that connector. Okay? And now that we have this, I just realized we never used the E or the I. Oh, well, whatever. Let's not worry about that. So then over here in this assembly, this final filler frame thing, let's just kind of throw something in here. Let's just throw this in here. And then let's see where that is. So that should be in the middle, right? We got to press F4, though. So hopefully we didn't make any horrible syntax mistakes, because... Okay, so this is not what I expected at all. It's the right kind of general shape. But the Y offset is like, what the hell is up with this Y offset? Why is there one in the middle? That makes no sense. So lug rect right here. In the offset for the Y, for whatever reason, is just like, huh, offset for the Y, we don't know what that is. And the reason for that is this should be LXY, not LX, right? So that's why we're only seeing movement on one axis. Okay, so if we do that, we're going to see that changed up a bit. It still doesn't look quite right. Now the question is this big enough? Is it too small? So I'm thinking this needs to be like a 0.25. To be correctly inset. But even that doesn't look like it has the correct span, right? So that looks more correct, but not quite correct. So I'm thinking if we look at this, 1, 2, 3, 4, 5, 5 lugs, right? Well, how many lugs are actually here, right? We got 1, 2. We got 1, 2, 3, 4, and 5. 5 lugs. 1, 2, 3, 4, and 5. Okay, 5 lugs between the holes. 5 lugs between the holes, which would make it 7 in width, right? So the width here is 7. Okay, and then this is probably like 7 plus 2, 7, 8, 9, I think. I'm just guessing. And then that also means that 5 divided by 2... On the y, we're going to take 5, and we're going to divide it by 2. Or on the x, we're going to take 5 divided by 2. I think. And on the x, we're going to take 9 minus 2 divided by 2, right? And this 5 divided by 2 is actually a 7 minus 2 divided by 2, right? We want to know how we're getting those values, so we can do it like that, so that we know how those values are being derived. And we're in a little bit better of a situation, but it still looks wrong. So to fix that, we gotta take this final frame thing here. Take that, remove that for a second. Just take one of these. All right, take this and take the connector. And kind of look at them side by side and see what the hell's going on. Like, what's wrong with our sizes here? So the first thought is, let's move this off, right? So L, Y, 0 plus, I don't know, 6 or something. And then this is going to be like ly 0 minus... Sure, why don't we just make it symmetrical for now? Okay, and then let's go look at this. That might be a little bit too much, maybe like a 4. Okay, so now that we have this, we can start just shifting things over, right? So we can say, hey, this connector, let's just leave the main thing in place. Or let's leave the main thing in place. That's the connector we want to figure out. So let's kind of like go, hey, Lx, 0 plus 4, I guess. We'll just take some guesses. We'll hone in on it as we get closer. So we can see that's not quite right. The spacing between here is off. So we know that in between here is 3 lugs, right? There's 3 lugs. And if there's 3 lugs, that means that midpoint to midpoint, there's only 2 lugs, right? Between hole to hole, right? Hole to hole, or actually, oh, sorry, 3 lugs between means we have 1, 2, 3, and then an extra one because we're using centers, right? So, so there's a 4 lug distance between these holes that should be there. And that's not what we have, so let's go over here in the component and say, for this LXY, where we're kind of like moving things, the offset on the X should be, we think it's 4 from center to center, right? So if we do that and we go F4, that's looking a little bit better. And then if everything looks kind of aligned there, so let's just change this on the X. So instead of plus 4, if we do plus maybe 3, we might actually be correctly aligned and we'll be in good territory on the X. Okay, cool. So that's lined up. So now when we're looking at this other axis, we got to fix that around, right? So I don't know exactly what the width of this needs to be. So we're going to just comment this out for now, right? And we're going to put this back over here. We're going to put this back here. And we're going to try to position it as correctly as possible, right? So F4, F4. And so where's the easiest place to kind of place this in terms of where it needs to be? I guess what we could do is we know from center point to center point on this diagram, it's 6.5. Center point to center point. And we don't want to go center point to center point, we want to go half of that. So when we're offsetting this, we want to go inch y. And we want to go 0 minus 0 plus 6.5 divided by 2. Should be the correct offset to get it directly between two of these kind of panel cores, if you will. And then from there... Okay, what the hell? Okay, what's going on here? Why do we have two things being rendered at the same time? F4. So there's that. Where the heck are we calling this? So at some point, this component is being called. Either that, or it's like, it doesn't know what the hell it's doing. Like, why is that there? Why is that there? Should all be commented out right now. F4. Okay, let's go look for it. Control H. Where the hell is this coming from? That's commented out. That's commented out, and line 8 in... Oh, it's the, does it have thickness? It does have thickness, okay. So it has thickness, so it must be coming from... It's the extrusion thing. It's probably in our assembly somewhere, right? Or maybe it's over here. Oh, it's this thing. So this thing right here needs to be this. Doesn't really matter, but... Okay, so now... I am gonna fucking throw something. Okay. So now we have this, and... Is it in the correct... So it looks like we have the... well, maybe not the correct width, but we have a nice width. We can see that we're off by like half of a lug here and half of a lug here, which means that we can go back into where we were making this component. Let's close this. And in this component on the y-axis, the offset on the y, we minus 2. We got to minus 1 more, so minus 3, I think. Right, okay, so that hole is now kind of where it needs to be. And then we also want to move it over by... Let's move it over to the left. I don't know how much to move it over to the left, but let's do like LX 0 minus... There's 3, 4, 5, maybe like 5. I don't know. I don't know what it exactly needs to be, but let's just do something, and then we'll correct it as we go. So that looks... that looks better, but not quite. So maybe 6, and if we do 6, we'll probably be in good standing. Yeah, so I'm not measuring anything, I'm just kind of like hacking it, right? So if we do this, I mean, that works out. And then what I was thinking is if we wanted to, we could try to fill this backing, right? But the problem with that is then it's going to be a lot harder to do stuff, so I don't know. If we fill this... Be interesting to see what kind of fill we can get in here. Uh-huh. Okay. So this is kind of a good connector. Now I'm thinking we don't want to get too fancy. Right? Like this connector here is pretty good. We could make it span halfway. We could make it span halfway so that, right, so that it kind of bridges this gap. That could be interesting. But what I really want to know is if we make a cutting sheet, right? So this connector is a basic connector, and it's going to work for what we need to do, right? So my thought is figure that out. Try to use some excess material. Try to get this cutting sheet to kind of just work, right? So I'm thinking that, see how we have this material in the middle here? I'm thinking we make kind of like little fan blades, right? So we make little fan blades that come off of here, and we make them rotate all the way around the table. And that way we have a way to enforce the trim. So if we look at the trim on this, if we're right here, we need something to make it stick out. One lug, 5 lugs. It needs to stick out at 5 lugs. This makes it stick out 1, 2. So we need to make it stick out a few more. We're thinking the way to do that is to take these pieces, right? So let's recreate this piece here, right? Simple polygon, right? Because we can salvage the material in here to use for the rest of this sculpture, right? And we can use it for the tips of here, right? And if we need to chop it down a little bit, we can chop it down a little bit, right? So the first thing we want to note is that we want to get the actual bounds of the entire table. So we made this kind of bound here, but we want another rectangle where we use the exact bounds. So 20.75, right? So FB equals 20.75 full bounds of entire table. Right, so this is the full bounds of the entire table. So we're going to say FB right here. And then panel bounds equals 5.25. Inner bounds of panel. Something like that, right? And then we'll take this, we'll make this a PB, we'll make this a PB, right? And then we'll go back over here and we'll just go F4. And hopefully we can see those bounds, right? We can see those bounds a little bit better. And that'll help us, this will help us figure out how much we need to extend, right? Because we want to make like a little fins. We can use these as little fins, bolt them in here, right? And then we can make them extend over to here, right? And if we put them... directly to the edges, That is kind of crazy, though. Oh, will that even look good? I don't know if it'll look good. But yeah, if we can save material, if we can save this material and not waste it, and use it on the border, that would be good. And I think if we're lucky, this will extend just to the very tip, right? And then on the tips, we can shave down the tips as need be when we're milling down the table, right? Okay, yeah, sure. So let's make sure we know what the size of this is, right? So if we're looking at the dimensions of this, the little fan blade is, let's make the fan blade in the same orientation as the other piece, so that when we make the cutting sheet, we don't have to do any rotation. 1, 2, 3, 4, 5. 5 on the long side. 1, 2, 3, 4, 5. It's 5 on the long side. On the top side, it's 1, 2, and 3, I believe, right? Because there's a bolt in between there. And then it goes down 1, 2, 3. And then it goes over here. Okay. So I just drew something out so I know what I'm working with. So 1, 2, and 3. Okay. 1, 2, and 3. Okay. Yeah, so I just drew out a little diagram so I can make a polygon of this. So in our components here, we have the connector ladder thingy component. We're going to make another component. Another component type, right? And thin edge scrap. Fin edge scrap. I guess we'll call it fin edge scrap. Sure, why not? And we'll throw that in there. And we'll just call it module CHS com fin, right? Because it's a fin, like as in on a shark or fan. Okay. And then in here, SCAD polygon, right? So I have a shortcut for SCAD polygon. We don't need this. This is an old shortcut. And we know we need 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 points. And so this needs one more point. Now, do we really want to make it this verbose? I don't know. Let's not worry about how verbose it is. Let's just get it to work first. So the 0th spot is just going to be 0, 0, right? So the first polygon, and we're going to go in a winding order from counterclockwise. So this X, this Y is not going to move. And then this Y here is going to go 0 plus 1 times lug. It's going to move over 1 lug. And then 1, 2, 3, 3, comma, 1, 2, 3, 1, 2, 3, comma 2. Okay, so the next point needs to be 3, comma 2. So, and it's still in the positive space. So 3, comma 2, right? Because this is at 0, comma 0. And then over here, after we do this point, we want to go 1, 2, 3, comma 1, 2, 3, 4, 5, 3, comma 5. So let's take this, copy this, paste it over here. So 3 on the X, 5 on this. Let's copy this because some of the values are going to be the same, right? Because we're only moving on one axis at a time. So if we paste this, and we know that we need to minus 3 on the X, so that makes it 0. And I'm not going to worry that this is a little bit, actually I am. And then this needs to be a 5, right? We got 5 points total. Okay. Okay, and then we're going to take this point, we're going to go in the extrusions file, and we're also going to make this as well. So we're going to duplicate this, and we have a fin, right? So we're going to call that fin for fin, a fan fin, a shark fin, whatever you want to call it. Then in here, I don't know where we want to use this yet, but I guess if we're looking at the final filler frame, it's not in here. Or is it? There's this nonsense, and then we have this thing here. Let's just throw it right in the middle, and then we'll worry about it after we know it looks good. So we're not even gonna look at the component. We're just gonna look at the extruded version because we think we know what we're doing, and so we think we can jump that many steps ahead. X05, unknown variable. So we know that the only place we have that variable is where we wrote this stuff. And indeed, 1, 2, 3, 4, and 5, because we duplicated this, but we forgot to change the variable name. So if we do that, and now we go F4, we should have the correct kind of polygon shape. And that sure looks correct to me. So we want to put some holes in it so we can bolt it. But before we do that, we have to go... Let's just try to put it at the bottom of the table. So I'm thinking I want the spikes out. I think that would be amusing. However, yeah, let's just do the spikes out. And let's just move it. So let's close the components. Let's close the extrusions. And then within here, let's just say on the z-axis, let's go inch y 0 minus 6.5 times 2. Rather than divided by 2, we're going to do times 2 to go from point to point. Actually, times 1.5 actually might be more correct. But let's just try this first, and then if this overshoots, I'm pretty certain that it's going to be 1.5. Yeah, so this should be times 1.5 to get where. Well, I don't know if we're going to be exactly where we need to be, but we're going to be relatively close. Okay, so relatively close. And the next thing we want to do is we just want to do like a log x, and then or a log y, and then we just want a 0 minus I don't know, 4 or 5 or 4.5 maybe. And then we'll take a look at that and see where that is positioned. Can we get all the way to the tip? So 4.5, a little bit too far. How about 3.5? So save that and see where that kind of puts us, right? So so if we do that, that completely tangents. So that's cool. But what I'm noticing is that if we do one more lug inset, it's going to be right on this border. So it's not going to quite work for us. Unless we want to painstakingly glue everything together. Guess what? I don't want to do that. But let's just go through with this. 2.5, right? F4. Yeah, so that's kind of like inset right in there. You can kind of see the overlapping polygons. You can see that it's like tangenting right here. So that's not enough to kind of screw that in, right? Now, if we want to get this to work, what we can do is we could make these pieces kind of special to where they have the outer rim, right? The outer rims we could give, we could make them slightly different, right? But the more specialized pieces we make, the harder this is going to be on us, right? But if we really don't want to waste that material, though, I think that's going to be a good option. Or you know what? Or we don't do that. Or we don't do that and we just have it centered, right? So we have some room, we have some buffer room, or maybe we don't do that. Maybe we have some buffer room so that when we mill down the table, the acrylic that's inside of it never comes out, right? So it's completely encased, right? So maybe that's a good thing, right? So yeah, we need to inset this 2 more lugs. So this is, instead of a 2.5, it's like a 0.5. And if we do that in F4, we're talking about being inset kind of like this, right? So, ooh, we got like kind of like a little kind of shark tooth kind of thing here. Okay, so for every one of these things we cut, let's forget about the thing in the middle, right? Let's forget about the thing in the middle. Or actually, hold on. If we do this, we want to make sure that we have a design that has enough fins, right? We don't want not enough fins. We have 1, 2, 3, 4, 5, 6, 7. We got like 8. We got 8 fins. So as long as this side here doesn't use any more than 8 fins, then we're actually okay, right? So we can get away with quite a lot here. So looking at this, let's open this up. Let's look at the top view a second. Do we offset on the X or the Y, or is this just naturally in a very odd position? Oh, it is naturally in an odd position because the origin is kind of like right here. So we're going to do like a LX and then do like a 0 minus 4.5. I don't know. Just take a guess and try to get it like over here or somewhere where it makes sense. Not F5. That's not what I wanted to use. F4. Okay, so not quite right. Actually, 5.5 is probably correct. Okay, yeah, so that's correct. That's right where we need it to be. And then we want to make like a little filler piece, right? So we want to make a little square in the middle of that fin. So in the component code, let's make a union difference thing. So let's go UDI2X64, right? So 64 columns, and we want to indent 2 levels of indentation. We're going to take this. This is our additive geometry, and then the subtractive geometry we want to make is just like a lug rect that is 1 by 1, and that's going to start at the origin, so we need to move it over by 1 on the X, 1, 2, 3, 1 comma 3. So we want to go LXY 1 comma 3, and if we do that, we should have a hole like right here. All right, if my math is correct. So close, so close. So it seems that I have it off by 1.5, 3.5. Okay, so now we're gonna do F4 to refresh, and now that hole should be nicely centered. Okay, cool. So that looks good, right? So the idea is that we can, we don't have to waste that material, right? We can put a fin here, then we can put a fin here, right? So we can put 4 little fins. Yeah, I can put 4 little fins, and then if we really want to, 1, 2, 3, 4, 5, 6. We could get 6 fins if we want. We're not using all the material, but we have more of it, right? And so we can just make this rotate counterclockwise, right? We can just make sure we have the correct rotational order. We bolt it all together, right? We can bolt it all together, and we can make absolutely sure it's correct, and then we just put it in a mold, right? And we have a little bit of padding on the side so that if we screw up, we can mill it down, right? I kind of like that. Okay. And then these kind of pieces kind of connect it. And so now we're thinking, okay, well, if that's how we want to roll, do we want to make it so that these pieces here, right, we're saying that, well, 8, so 1, 2, 3, okay, hold on. So 1, 2, 3, and 4, right? 1, 2, 3, 4, 5, 6, 7, 8. So this has 8. Again, 4 here, but on the corner, we're going to need those 8, right? So I think that 4 fins per piece, I think, is fine. Okay, 4 fins per piece. That looks good. So the next thing is we want to make a cutting sheet. We want to make a cutting sheet with the parts we have and want to see how all this fits together. Does it fit together nicely? Do we want to adjust the sizes based on what fits, right? So this kind of fin piece actually just kind of fits within the scrap that we've cut. So we don't actually have to worry about that. We just have to drill, a square within the negative space of this pattern correctly, and then that'll just work. So let's create a cutting sheet. So let's go into here. Let's go File, New. Let's create a cutting sheet. We're going to save this as, let's just say, let's try to cut it out of a 10 by 10, right? So let's do CHS cut 10 by 10. And the reason I want to try to create a cutting sheet out of a 10 by 10 is because a lot of the acrylic I've been producing is 10 by 10 sheets. So if we can fit it into a 10 by 10, that would be nice. It's not necessary, but we're going to try to work with the 10 by 10 constraint, and then depending on if that works or not, we'll go from there. So in this cutting sheet, let's just open this up. Let's go over into, let's close the components thing, and within here, let's just comment out some of this stuff, right? So let's just comment out this final filler frame thing, right? And then let's just call this cutting sheet. And that's not actually going to work right now because we have not included the cutting sheets. So cutting sheets should come after the components. They don't use the extrusion, so they don't have. So they could technically come like right after here if we wanted to. So here's our cutting sheets. Let's go back over here. Now the function should exist, or not, because we don't know what we're doing. So cut. Because we have to name it module. Okay, so now if we name it module, we have this 10 by 10 rectangle, and we want to, the first thing we want to do is we decided that in the assembly that, screw it, all of them are going to be these both-way parts, right? The more uniform the design is, the less variation in parts we have, the better. Because it's less things to keep track of, less things to remember to cut, right? The inventory is easier. Okay, so we got this thing here, right? And so let's do like LXY 0 minus, I don't know, 7, 0 minus 7 or something. And try to get it on the negative quadrant, right? And then from there we can mirror it radially and see how that works out for us. So not quite. 1, 2, maybe 3 more. So I'd say 10 and 10. Possibly fractional, but like 10 and 10, or 10.5, 10.5. So yeah, 10 actually, this is a half and that's a half, so that's actually 11 and 11. Okay. Okay, so there, we got that there. And my concern, so let's go mirror this radially first of all. First of all, mirror it radially, right? And if we mirror it radially... Oh, hey, how's it going? So... Yeah, so, yeah, I'm making a little lattice. Okay, well, my bitrate is blue right now, so maybe if I'm lucky, I'm not dropping any frames right now. So basically, right, we have this tabletop, right? And we're going to create a unibody, just a gigantic epoxy slab that's just going to go over this. I keep on thinking of the easiest way to get something done to a professional level, right? And yeah, there's like tolerance stacking we have to think about, and there's laser cutting time. There's my capabilities as artisan, I guess. So I think the easiest thing to do is just make like a giant epoxy slab and then embed it with a certain pattern. So right now I'm working on a cutting sheet, but I can show you what I was working on. So I'm going to comment out this 10 by 10 thing here. I'm working on a cutting sheet. If I comment this out for a second, right? So go F4. So, right, so this is the lattice work. Right, I'm going to take this lattice work and I'm going to bolt it all together, right? So I'm going to bolt together a very fancy lattice. And this lattice is eventually going to be unibody. So there's going to be connectors that connect each one of these core modules to each other until I have this very fancy, intricate web work. And that web work is going to displace a lot of the epoxy. So it's going to cost me less because I already have a whole bunch of acrylic, right? So I can cut this out of all the acrylic I have, make it shiny blue or black. I'm thinking black because the fill I'm going to use is going to be like a I'm going to use like clear epoxy with some like blue mica powder. But yeah, so that's kind of where I am right now. I'm running out of money, so I'm panicking. I'm thinking of designing. Designing like laser cutting files and trying to sell those. I'm just going to try to keep my cool and work on the game engine a little bit every day. Work on Etsy store stuff every day. Oh yeah, so I have Etsy. I did my Etsy store. Let me show you that for a second. Etsy store. Let's go to Etsy for a second. Let's pull this down here for a second. On Etsy. So www.etsy.com. It's still a work in progress. Every day I've been kind of dropping my prices by $1 so that eventually maybe something will sell. But if we look at here, right, so I don't think anything's sold yet, but right, so we got 9 sheets of 10 by 10 acrylic. We got 36 sheets of 10 by 10 black acrylic in a nice little box. Alright, then we have a very expensive crate, because this crate takes me forever to make, so made to order. I don't think anyone's going to buy this, but the more stuff I have in my store, the more ways people can find me. So even if no one's going to buy this, it still brings people to my store. So, no. So if we want to look at the shop, let's go to the shop. Alright, so if I throw that in there, bam! Throw that into the chat. Oh yeah, so this is what I'm working on. Right, so I have some washers. I have some felt washers I made for assembling the table, because we don't want to wreck the table when we bolt it together, because the metal can be very harsh on the surface of the acrylic, and the design is to be bolted together. So felt washers to fix that problem. Anyways, on Etsy since 2020, yeah. So anyways, I'm working on that. I'm trying to figure out what the heck I'm doing. But yeah, I got nothing going on yet, but I'm gonna try to keep on going until maybe somebody likes what I have, right? So right now, not too much stuff, but I'm gonna try to up the quality. Right now, I already got a quality. I made a photo box. Like I made a correct photo. I didn't do professional photography. I did this photography myself. I made like a light box with like lights and diffuse lighting and white backgrounds, so that's really easy to clean up the photos. And I'm pretty proud of these photos. Right, like this photo has no digital cleanup whatsoever. It just looks that way. Right, so if we go in here, right, so some of these pictures I didn't clean up. So like if we look at this, we can see, right, that this isn't cleaned up, right? You can see you can see the light box structure that I made, right? Yeah, so there we go, right? So working on this and some other stuff. One thing at a time, try not to die, blah, blah, blah. 906, I actually have to take drugs and then do some more push-ups. What's my push-ups look like here? I got 60 done. So I'm going to, first of all, I'm going to go F4 here. I want to work on this cutting sheet. So if I render this really quick, ooh, that is not working because mixing 2D and 3D objects. So in this thing here, this should be CHS component, right? So that was the shorthand code I have is for the extrusion. Okay, so now if we do that and we run this now, okay, now we have a cutting sheet. So these parts are merged together. We're going to have to fix that, but one thing at a time. Well, I mean, actually, could actually see that kind of working. No, let's not do that. Well, actually, it's less to bolt together. I do like the heatsink kind of pattern here that I have bolted together, though. I'll have to think about it. I actually like that pattern. Now, visually, that pattern is pretty cool. No, because then it changes how everything. No. Okay, so we got this part, and then also we have another component. That is it's the connector component. So I don't know how much space this takes up. Okay, so not too bad, right? We have a lot of wasted space here, though. So it would be beneficial to us to try to optimize how much space is being used here, because then we don't, right? Because we're going to use these little fins, and then we can use this material as well. So right now we have like a lot of extra space. The question is, if we look at our cutting sheet, right? If we look at our cutting sheet, how much can we afford to widen this without affecting? So this filler frame, we're going to take this connector code. So this is the only connector, right? We're going to take this connector and we're going to throw it into the filler frame so that we can visualize where one of the connectors is supposed to be. Okay. So here's where one of the connectors are supposed to be. We can see that if we do this, we have the ability to widen it a bit, right? So we can widen it by maybe 1 lug on each side. Or actually, if we widen it by 1 lug on each side, we got to get rid of these little nubs, right? But we can get rid of those nubs. If we get rid of those nubs, then we can, right? Those nubs are like kind of like, I changed my mind on those nubs. Let's get rid of those nubs on the end. So if we go into the code for the components, let's just go into the code for the components, and let's go find the original components. So here's our inner core components, and we have the outer edges, and then somewhere in here we have like nubs, so cap thorns. So cap thorns are these little things here, I believe. So if we just comment those out, right, so 1, 2, 3, and 4, and space, save, go F4, these little nubs should get rid of, right? Okay, so with that, if we get rid of those little nubs, then we have more room to expand this, right? So now that we have more room to expand that, let's go up here to where we're making that shape. So here is, well, this is the fin, here is the connector, and the connector is a lug rack that is kind of like 7 by whatever the heck, and we could expand it by 2, right? So instead of 7, we can make it 8, 9, right? F4. And if we do that, it kind of, I'm a little bit worried that that is not correct. Nope, that's actually correct. So let's make it like 8.2 or 8.8 and make sure that this is exactly tangent. Okay, yeah, so that is. So we can make, let's put that back to 9. And the question is, okay, if we throw that in the cutting sheet, so everything kind of lines up nice, but if we throw that in the cutting sheet, is that good, or is that too big now? So we're going to go here to here where we're kind of messing around, and we're going to comment this out, we're going to put this back in, and we're going to look at that final cutting sheet, and we're just trying to optimize the space here. So we made it a little bit bigger, but we have almost, like, we can use like 2 more lugs worth of space. So we're gonna go in here and say, okay, do we have the ability to add 2 more lugs to this? Well, we've already kind of extended as far as we can there. But we could extend 1 lug here, right? We could extend 1 lug on this side. But if we do that, the problem with that is then, with how this connector works, right? This hits this side right here, right? So the other connector is going to hit up to here. So if we make it any bigger, they're going to start to overlap. Well, we can chamfer that. We can chamfer that and figure that out. We could chamfer it. We got like a little chamfer extension. So these connectors, I think the connectors would probably look best if we have just a slight little chamfer, right? And then we actually, I think this is already too much, right? If this hits here, then this one needs to hit here as well. So this already needs a chamfer, right? It's already past the midline, right? So this is the midline here. It's already past that midline, so it already needs to be chamfered like that. Okay, so it already needs to be chamfered, so screw it. Okay, let's go back to the frame part, and then I actually have to take drugs because it's 9. So we got less wasted material, and hey, since we got rid of those flanges, since we got rid of those little flange things, we can actually compress this a little bit more. So in the cutting sheet, originally we kind of offsetted by a lot. We can, not this thing, in the cutting sheet, we had 11 and 11. We can remove that and say, instead of 11, we can say 9 and 9. Right? And we can reduce the amount of space taken up there. Ooh, maybe not, because this is... did I say 9 and 9? Let's do 10 and 10. Okay. F4. 10 and 10. 10.5 and 10.5. Let's make an offset variable called O, or yeah, O for offset. Put it in there. Let's go F4. Okay, that's good there. We need to change the tolerances so that this kind of works. Well, I mean, actually, no. We could just make it one unibody shape, right? We can make it one unibody shape, and then we could use these spacers to just connect it together, right? We could do that. And if we do that, we might want to think about making these little sticks, right? They could be little sticks and we could connect the little sticks together. Oh wait, no, wait, we didn't want to do this because it changes the way we have to... It changes the design, right? Everything doesn't go in evenly that way. So if we wanted to do that, right, so... if we made this like, instead of 10.5, 8.5, right? And we overlapped it that way. That would be what we're talking here, right? The problem with that is then there's no room for anything, right? There's no room for any of that negative space in the middle, right? And I kind of like that negative space. I kind of like that negative space. But I will say the... I will say doing it like that, we have some advantages, don't we? So 8.5, does that need to be like 9.5? I don't think that's correct because they should be overlapped and we should see more holes where they're being bolted together, right? So, yeah. 9.5, 10.5. It's like, not 10, this would be 10. This would be a perfect 10 right here. So it should be 9.5, right? 9.5? And then we should have 3 holes. There's 3 holes right in the middle there, right? And that's not what we're getting. It almost looks like it's either offshooted by... It's off by 0.5 in one direction or the other. Okay, so that's not quite right. That's too much. So we're thinking 9, right? There we go. Yeah, so think 9 like that. And then let's get rid of this connector thing, because it's merging with other stuff for a second. And say, you know what, we have a lot of room. We have a lot of room where we could put these connector pieces and we could go boom, boom, boom right in between there. And that would actually be pretty badass, right? Less surface area, less cutting, less weird asymmetry, right? So a little bit easier to put together. I think I'm gonna do this. I think I'm gonna steal this and call this CHS Com Uni for unibody. Unibody core. Unibody core. And then in the components, we have the so module CHS Com Uni, right? Unibody core. All right, so all we did is take that one thing, and then let's make a note of this unibody core, and then I do have to take my drugs because I'm 19 minutes late. Okay, so now that we have this unibody core, first things is if we go F4 here, is it still there? Did we already replace it? Yeah, we already put it in here, right? So if we do this, F4 should go away. Put in the unibody core right here, F4, it's right there. So this core I think is nice, right? So if we look at the thing here, see how we have these 3 in a row, those 3 holes in a row? Let's make sure those 3 holes in a row are indeed present in this other layout we have. Yeah, we see these 3 holes in a row, right? So it's the same kind of deal, but rather than having this this staggering kind of thing here, we just make it unibody, right? So we have one layer where we put all of these weird panel designs, and then the next layer we put the connectors, and the next layer we put the panels, and then we just alternate, right? And then we can get kind of a nice thing where we have kind of like we can get 1, 2, 3, 4, 5 panels in a row, and then 1, 2, 3, 4 connectors. In terms of when we're looking at the Z height cross section, right? We'll have 5 panels, right? So 1 in the dead center, then 2 on the exterior, and then 2 more that are between the center and the exteriors, right? 5 unibody panels, and then we'll have 4 layers of connectors, and then we have a little bit of liberty as to how long these connectors get to be, right? These connectors, the connectors that are going to connect this shape, right? These shapes together can be a various sizes, right? So with that, I think we have enough to use up like 100% of the material in here, right? So we can make connectors that connect 2 of these panels by cutting them out from the middle of here. And then we can make these little fin designs from this scrap over here. That way we're not wasting much material, and it's like this optimum filler thing. So is this a cool pattern to be putting in stuff? I don't know, but we're just going to make a cool geometric thingy-mabobber and hope that somebody is like, hey, that's awesome, I want to pay a few $1,000s for it, right? That's what we're going to try. So what we're going to do now is we're going to say we're going to try another 20 minutes, and I'm going to take my drugs. I'm going to try to do more push-ups, and then I'll be back. Damn it. Okay, I have food I want to finish eating, so I'm going to start another stream later, I think. So this was stream 178. I'll keep on continuing on the fancy filler kind of stuff later.